Hello and assalamu alaikum. My name is Fakisha, and in this video we will be discussing some AVR microcontroller C programming, and we will see the simulation. So here I have made a circuit of um, our program. That is, we have to show the ASCII characters of from 0 to 0, 1, 2, 3, 4, 5, and A, B, C, and D letters or characters on port B. So this is port B. I'm attached the LEDs, and the sequence of LEDs will show the their ASCII codes of respective numbers. So first you will see no LED glowing because if it indicates 0, then for 1 we will have two LEDs glowing, and similarly ASCII characters are uh, LEDs will be shown differently. So this is for 1, these two LEDs are glowing. If I connect a BCD display, so then you can see the display of 1, 2, 3, and how the sequence flows. And this is for 2 now, and furthermore more LEDs will glow and some will go off, and it will represent the ASCII code. So this is for 3, this combination is for 3 in ASCII characters or hexadecimal values of these ASCII characters. So this is for 4, and similarly this will flow up to 8D. So uh, I'll move on to our next program. So here we have to write an AVRC program to toggle all the bits of port B 200 times. So these bits are just toggling respectively. So they have to just move up and down, so the binary toggles. So if I move up to over here, so what we have over here is we have to run the following program on simulator and examine the result. So this actually shows that port B shows us the multiplication or the sorry, the port B shows the add function, the port C shows us OR function, and port D shows us XOR function. So those are uh, 35 in hexadecimal, and F, that is uh, 4 zeros and 4 ones are being added, and these adding values are displayed on port B, and port C shows us the OR function of 0 cross 04 or 0 cross 68. The value shows of this is on port C, and on port D we have the value of 0 cross 54 x or 0 cross 78. So if we move on further, so in this program we have to monitor bit 5 of port B, and if it's high we have to send the value on the port D. So here I have given on value of port B, so you can see it has been toggled. If I show you again, so there's one. If I turn it 0, you will see the value has changed. Similarly, change the bits, or toggle connection changes. So further we have this, and in this program we have We have to write a C program to get a byte of data from port B and send it to port C. So we are getting data from port B and we are getting output from port C. If I run this simulation, you can see if I turn this button on, I get LED glowing over here. Similarly, if I turn this bit on, LED glowing. So these all show the output, any sequence I want. So in this way, our program is working. So then we are left with this one. In this program, we have to show from 0 to 99 numbers on this PC display. It just flows very fast, so I will pause to show numbers. So this is 43, 49, 46, 41. So it is flowing very fast. When we go on the hardware, we will see it because there we have added some delays also. So moving on to the next ones, we have now this one. I think this one is done. Mm. So over here we have sequences. So when the number is even on the input, uh, then blink alternative LEDs will glow, and when it's on the port C, and if the number is even, then blink LED at port C one after another from least significant bit to most significant bit. So if I make it 2, or we make it 0, 1, 0, you will see a decrement one after another. I do this. Okay. So it completes one cycle first, then it follows another. So in this way, this program runs. So if I move on to next, I think nothing is left behind. So now we'll move on towards our program. So this is the program for shifting from getting input from one port and providing output to another port. So this is a standard library for AVR microcontroller. This is main function. This is unsigned character, that is temp, and DDRB is an input port and DDRD is an output port. and while we are storing the pin B input in temp and getting it and stored in port D temp and displaying it as the output. So in this program, we are including a delay. We are including a crystal. We're saying that 16 megahertz crystal is being used. This is AVR microcontroller library, standard library. This is delay function or library, and then we have over here we are storing a list of characters that is 0 to D and in char Z. So DDRB is an output port, and in loop we are displaying this character in ASCII. There are ASCII characters in hexadecimal in this loop. So this loop calls one by one each character, and its ASCII in hexadecimal is being shown on port B. So over here we have the same libraries, and in here DDRB is an output port. C and D also are output ports, and port B has this adding function input over here, and a delay of 500 millis 500 milliseconds. Uh, we have this then port C has this OR function, and after displaying this we have a delay, and then we have XOR operation, that is 0 plus 54 XOR operation with 0 plus 78, and this is being shown. Then we have a toggle operation at the end. So in this program, we have to show 0 to 99 character numbers on basic display or from port in 8-bit form. So we are using a for loop over here that is running from 0 to 255, and we are getting out declaring output port is B port, and this port B is then Z, and this gets the output from 0 to 99. Uh, then we have this program that is when we have DDRB is an input port, D is an output port, while uses the if command is pin B, and this is adding with this one, that is 0B 1000000. So pin port D is outputting this 0 cos 35, and or else if this is not the case, uh, we will get all the AA on port D. So that was it from this video. Thank you very much.